Hello, class. I received a few questions from the 6-2 StatLab homework. I had questions on number 6 and number 7, so I'd like to try to complete 6 and 7 in one video. We'll see how I do. The first question says, create a scatter diagram. So here's my data. If I click on this little box here, I can open this data up into StatCrunch. And then I can, all right, so here's my data, my X, my Y. I can quickly graph this. So I click Graph. I scroll down to Scatter Plot. X is X and Y is Y. And I press Compute. And let's see if we can make this a little bit bigger. All right, so it looks like my data starting at 1 kind of goes up and then starts to come down. So I can immediately eliminate letter C and letter D. Letters A and B are the only ones that look like they fall from left to right. And so you look at my scale for A and B, they both start at 0. And my window starts at 1. So if I shift everything over by 1, I see these two dots are too close together. Right? It looks like my data from 1 goes up to 2, right? From 1 to 2. And from 1 to 2, my data goes up. So I'm going to select choice B, check answer. I get the nice work, which is great. Next, it says there appears to be a, I guess, if I take away this one point, this could resemble a linear relationship. And since it falls from left to right, it's negative. I check my answer. Okay. And then it says, okay, can we come up with our regression equation? So let's take a look. Now, they give us some information up here. And I want to see, can I come up with the equation using StatCrunch? I press open in StatCrunch. And again, I can press Stat, look for regression, simple linear. My X is again X, my Y is again Y. Let's see, everything else looks good. I press Compute. And inside, right, we have y equals mx plus b. The m would be our slope. So here's my slope. And you have to be careful. Some of the problems have you go 3 decimal places. Some have you go 5. So this has me around 3 decimal places. So I'm going to try to cut and paste that. Okay. And then to get the second part, my intercept, my y-intercept, 3 decimal places. Now I noticed that I'm going to have to round that to 470, right, if I go 3 decimal places. So I will chop this off here, and then I will round the 69. That's going to become 70. Let's see if I've rounded correctly. Okay, looks good. And then the last part, let's see here. It says choose the correct graph. So again, in StatCrunch, when I created this area, I failed to mention there's a little arrow key down here that if I press to the right, it will give me a nice graph. So again, I can eliminate choice A because that rises from left to right. I can eliminate choice D because that rises from left to right. So only choice B and C fall from left to right. And if you look, choice B, my line splits my first 2 data points, similar to my graph here, right? Here are my first 2 data points and my line splits it. So I'm going to press choice B, and I get the good job next question. So let's take a look at question 7. 7 is similar. So we have an engineer. We want to determine how the weight of a gas-powered car affects the mileage. So I assume the heavier the car, the poorer the gas mileage, unless maybe if you're like traveling downhill the whole way. So I click here to get my data table. So you can see the weight and how many miles per gallon we have. So I open this up in StatCrunch. And to find the least squares regression line, I will press Stat, Regression, Simple Linear. My X is X and my Y is Y. I press Compute. And again, now notice this problem has me round 5 decimal places. So my slope is 5 decimal places. 1, 2, 3, 4, 5. So I have to round that last digit up to an 8. I'll place that in here, and I had to round up. And it's tricky. This last piece, the intercept, you have to round to 2 decimal places. So you'll definitely get an error if you round this to 5 decimal places. So here's my intercept, and I will paste that here, and I will press check answer. I get the well done. I feel good about that. So let's see, we have to interpret the slope. So this was my slope, and this was my y-intercept. So it says, okay, so basically, without reading this, I believe every time my car, the weight is increased by 1 pound, my gas mileage will decrease by this number here, this 0.00708. And in theory, if my car weighed 0, the gas mileage would be 43 miles per gallon. But of course, we can't have a car that weighs 0 pounds. So a y-intercept or an intercept of 43 miles per gallon for a car that weighs 0 is invalid. It doesn't make any sense. Let's see. For every pound added to the weight of the car, the gas mileage will decrease by 0.00708 miles per gallon. A weightless car will get 43 miles per gallon on average. That's one option, but again, it doesn't make sense. A weightless car, a car that weighs 0, shouldn't get any miles per gallon, right? So I look at choice B. A weightless car will get 43 miles per gallon. Again, we can't have a weightless car. Part C, for every pound added to the weight of the car, the gas mileage will decrease by 0.00708 miles per gallon on average. It is not appropriate to interpret the y-intercept, right? So the y-intercept means if I substitute in 0 for x, my y-intercept would be this 43.19. It's not appropriate, right? There's no such thing as a weightless car, so it wouldn't make any sense. In theory, yes, if we could build a weightless car, it would get 43.1 miles per gallon, but we cannot create a weightless car, so it's not appropriate to interpret the y-intercept. That's tricky. I'm going to press check answer. Oh, it worked. And then the last piece, it says a certain gas-powered car weighs 3,700 pounds. So now we know the weight. The weight's 3,700 pounds. So I can plug in or substitute 3,700 into x, which represents my weight, to see, do I get more than 19 gallons per mile or less? So I have to pull out my calculator. Okay, so let's use this equation. Negative 0.00708 times the 3,700 pounds, right? So we have a car that weighs 3,700 pounds, and then we add this 43.19, and it looks like the car will get almost 17 gallons per mile, right? So a car that's this heavy should get about 17 miles per gallon, which is less than this. So is the miles per gallon of this car above average or below average? So the answer would be it's above average, right? This car is getting 19 miles per gallon, and my calculations suggest that a car that weighs that only should get 16.99 gallons per mile. So this car is above average. I press final check, and it worked. I hope that helps. Thank you for watching. Have a great day.